This is one of the most common way a hacker can snoop on your traffic. How can you catch them? In this video, I will show you the signature of an RP spoofing attack and how to catch them using Snort. What is ARP spoofing? It is an attack on the address resolution protocol, which occurs on the layer 2 of the OSI network model. Address resolution protocol is responsible for mapping a device's IP address to a unique hardware address. Aside from associating an IP to a MAC address, address resolution protocol plays an important role in sending data to another device on the same network. These data are called frames on layer 2 of OSI model. Whenever a frame needs to be transmitted to a destination IP address, the sender will send a broadcast message to all devices in the network asking for the MAC address associated with the IP address. This is called an ARP request. Under normal circumstances, the legitimate device will reply back while others will just ignore the message. This is now the ARP reply. Once the sender received the reply, it will now put the destination MAC address into the frame header and send that frame to the destination. But what if a non-legitimate device intervenes in the normal ARP communication and decided to respond to the ARP request? This is ARP spoofing. Rather than waiting for an ARP request, an attacker intentionally sends out an ARP reply targeting the victim device. This is also called gratuitous ARP, which is a common technique used to provide high availability to network devices, but can be used on malicious purposes as well. Once the victim receives this frame, it will use the attacker's MAC address to any frame it wants to send to a legitimate device. So instead of going to the intended destination, the frame will now go to the attacker's device. This allows the attacker to do all sorts of malicious activities such as sniffing traffic and denial of service. Now that we already have a basic understanding of ARP spoofing, how can we use Snort to detect it? Snort is an intrusion detection and prevention system which is maintained by Cisco Talos, one of the leading threat intelligence group in the world, and also the maintainer of ClamAV. It is a signature-based IPS that reassemble and normalize network packets in order to evaluate against a set of rules. These are rule sets which we will discuss more later. Although Snort is open source, it also provides subscriptions for those who want up-to-date rule sets for better detection of advanced exploits and zero-day vulnerabilities. This is currently available in 2 versions. Snort 2 is the legacy version which was written in C. In this video, we will focus on the newer version, Snort 3, which was written in C++ and contains a lot of improvements compared to Snort 2. Before setting up Snort, let's try to simulate first an ARP spoofing attack. I will use an ARP spoofing attack to sniff the web traffic from my smartphone device. In order to do that, I will use a tool to send a gratuitous frame to my smartphone, telling it that I am the network router. As a result, whenever my smartphone accesses the internet, it will send the packet to me instead of sending it to the legitimate router. That means I can see all the websites my smartphone wants to access. To confirm that the attack is working, I will use Wireshark on my Kali machine and observe the traffic. The tool that I will use to send gratuitous ARP frame to my smartphone is ARP Spoof. There are other tools you can use, but this is the most common, and I believe this is already included in the default Kali installation. First, I will scan my local network to see if I can reach the IP of my smartphone. This type of scan only do an ARP scan and disables port scan, which is useful for discovering devices quickly. Once I receive the frames from my smartphone, I need to forward it again to the router so that my smartphone can still access the internet. In order to do that, I will enable IP forwarding on my Kali. Without this, my Kali will just drop the frames it received, effectively doing a denial of service to my smartphone. Then I'm ready to run ARP spoof to send the gratuitous frames. I need to specify my smartphone IP as my target, the router IP I want to imitate, and the interface where I will use for spoofing. Let's confirm in Wireshark if our attack is working properly. I will filter my smartphone IP and disregard any retransmission packets since these are common in spoofing attacks. As we see by looking at the source IP address, I can have an idea on who my smartphone is talking to. This confirms that our attack is successful. Now let's configure Snort. Snort can be installed like any normal Debian package. Snort operates on rule set. A basic rule consists of an action, source, destination, message to display, content to look for in a packet, and rule number. In detecting ARP spoofing, we will use a special type of rule, which is a preprocessor rule. I didn't dig deeper on how different are preprocessor rules compared to normal rules, but based from what I read, they provide additional processing functionality to the core engine. The ARP preprocessor works by tracking inconsistencies in Layer 2 addresses. So in the main Snort configuration file, I will enable it and tell it to track my network router IP and MAC address. Then I will create the actual preprocessor rule. The format is similar to a normal rule, but with some differences. There is no source and destination address beside the action. I specify a message that can easily identify the alert. Both SID and revision should be related with each other. Revision number is the version of Snort rule and must be incremented for every change. Unlike SID, where you can specify whatever you want, generator ID must be set correctly. This tells the rule what part of Snort generated the event. Generator ID for ARP preprocessor is 112. To check for other events, use the following command. Lastly, metadata and class type are additional information that identifies the rule. Do note that unlike metadata, which can contain arbitrary number of key value pairs, class type must only contain one value. All required configurations are already in place, so I'm ready to launch Snort now. The command line options include the interface I need to listen, main Snort configuration file, and the rule I just created. I will also run in fast mode, which will provide simpler output. Upon firing this, we can see it detected some hits. I needed to generate network activity on my smartphone by browsing the web in order for the frames to flow through the network. Using this robust tool, you can easily implement monitoring on your network by hooking this up to different options such as scripts that will send you email or Slack notifications. I hope you learned a lot from this video. See you on the next one.